Hello, this is Maths with Lemon, and in this topic we will see the points of inflection. Very common question in IB past papers. Let's see it. It's not so difficult topic. There are some basic steps that you have to do, but generally it's easy. Now let's see the problem. Consider the curve y equals 2x cubed minus 9x squared plus 12x plus 5. Find dy over dx, meaning the first derivative. Let me calculate it. Dy over dx is equal derivative of 2x cubed 6x squared minus 18x plus 12. You should be able to do the first and the second derivative for the points of inflection. Now that's A. Let's see B. Hence, find the coordinates of the points on the curve at which the first derivative dy over dx is 0. So basically I need to find where are these points where they make the first derivative 0. So basically I have to solve, if I will divide by 6 the whole equation, minus 3x plus 2, right, plus 2, 0. Here I will use a quadratic formula, x1, 2, minus b, 3, plus minus square root 9 b squared minus 4ac minus 8 over 2, which is 3 plus minus 1 over 2. So the answer solution is 3 plus 1, 4, divided by 2, 2, and the 1, 2 over 2, 1. So the solutions are x equals 1 and x equals 2. This is where my first derivative is 0. C. Find the second derivative. Okay, let's come here. The second derivative, that's how I denote it, is x minus 18. That's my second derivative. Hence determine whether the points are local maxima or local minima. Now you see here I found the 2 points. I want now to see if these points, which one is maximum or minimum, or maybe both of them, we don't know. How I do it? For the first value, x equals 1, I am going to my second derivative and put the value. If it's negative, it's local maxima. If it's positive, it's local minima. Let's see it. 12 times 1 minus 18, which is minus 6, which is less than 0, which means my function at this point is what? Concave down. So basically I have a maximum. Then let me see it. When x is 2, let me see what's happening. 12 times 2 minus 18 is 24 minus 8, 6, which is bigger than 0, which means is the concave up, which means I have minimum. So easy. I think it's easy, Now find the coordinates of the point of inflection of the curve. What is the point of inflection, basically? That's the whole question. Now, if you will see, let's say I have a function, I have here my graph. Let's say that I have this point here. If you see, my curve goes, it's concave down and then goes concave up. A point of inflection, this is an example, is here, when the more or less here, is where the concavity changes. So basically here, how I can determine on this function here where's the point of inflection? Very easy. I will just see where my second derivative is 0. That's where I find the points of inflection. So basically, where my second derivative is 0, it's when my equation, my second derivative, 12x minus 18, is 0, which is 12x equals 18, so x is 18 over 12, which is 3 over 2, which is 1.5. So basically at the point 1.5 is where I have my inflection point.